Welcome to lesson number 5, Q1P1, The Nature of Science, Measuring and Using Data. Our lesson objectives and anchors for today. The objectives for today are to accurately measure mass, length, volume, temperature, and time using the appropriate instruments, and to organize and interpret measurements in tables and charts. This will help you with 2 anchors: apply appropriate instruments for a specific purpose and describe the information the instrument can provide, and explain, interpret, and apply scientific, environmental, or technological knowledge presented in a variety of formats, as well as get us ready for an upcoming anchor. You may be wondering, why am I learning about this? Well, it's useful for your life and for the science lab. In this lesson, you'll learn how to use household and scientific tools to accurately measure properties like time, temperature, volume, length, and mass. Did you know that even the slightest change to a baking recipe can wreak havoc on your results? After this lesson, you will show what you've learned by making the necessary measurements to create the perfect loaf of bread. So, let's get started. First, we're going to talk about instruments of measurement. Simple instruments allow you to take measurements while conducting scientific research. There are 5 instruments we're going to talk about in the science lab for measuring the 5 properties we talked about in making measurements. Length is measured with a ruler, so we'll measure meters, centimeters, or millimeters with rulers. Mass is measured with a balance. That's how you'll find out how many grams something has in mass. For volume, we'll use a graduated cylinder to find out the number of milliliters or liters something contains. Temperature will be measured with a thermometer in degrees Celsius for science. As you can see, the thermometer here has both Fahrenheit and Celsius, as some do. Time will be measured with a stopwatch or a clock. Now, on to some tips for accurate measurements. If you're looking at that graduated cylinder and you're thinking maybe you've never worked with one of those before, don't worry, because there is actually a tip coming up just about those. So, for accurate measurements, rulers, graduated cylinders, and thermometers use large and small lines to help you reach an accurate measurement. There are a few steps you'll need to follow. First, identify the units of the large lines. On the ruler here on this slide, we see cm, which stands for centimeters. So we know that each of those large lines, starting from the 0, are 1, 2, 3, 4 centimeters. Next, we need to count the small lines between each pair of large lines. Let's focus between the 3 and 4 and count those little lines. We can see there are 9 lines. So if you look at the list on the slide, 9 lines counted means each one is 0.1 of the large units. That means in this case, they're each 0.1 centimeters. If you counted only 4 lines, they would be worth 0.2 of the large units. 3 lines, it would be worth 0.25 of the large units. You can check you've got the right one by starting, let's say, with the number 3 and counting by 0.1 for each of those 9 lines. If we're correct and they're each worth 0.1, we should come to 4 right when we hit line number 4. So if you count them down, you can follow along. You have 3, 3.1, 3.2, 3.3, 3.4, 3.5 is the one that's a little bit longer, 3.6, 3.7, 3.8, 3.9, and 4 centimeters right at the next line. So we know we've done that correctly. Now, to measure this paperclip, we have to find and record the nearest large line that's smaller than our object. So we see the paperclip, first of all, is starting at the 0. That's very important for rulers. Thermometers and graduated cylinders will automatically start at the right place. But for a ruler, you need to make sure you line something up to the 0 mark, not the edge of the ruler. Your measurements will be too short if you do that. So from the 0, we see that the other end is between the 2 and the 3. We want the line smaller than your object, so that would be 2 centimeters. Now, find the nearest small line to your object. This one doesn't have to be smaller or longer, just whichever one is the closest. And there we have it. So that's 0.7. If we count down from the 2, it's 0.7. I'm going to add those up to find the total length, or if you're using a graduated cylinder, the total volume, a thermometer, the total temperature. So we have 2 centimeters plus 0.7 centimeters, and the paper clip is 2.7 centimeters long. Alright, we're going to practice that again, and this time with a little bit of extra information about graduated cylinders. Often, liquids in a graduated cylinder form a curve called a meniscus. Take a look here. This yellow liquid has kind of a brownish surface. It's easy to see. That is the bottom of the meniscus. So you're going to use that bottom middle spot, the lowest point, to measure the volume. We're going to run through the same steps we did last time to find the volume at the bottom of the meniscus there. First of all, the units say ml, which means milliliters, and the large lines are in groups of 10. So that 50 is 50 milliliters, the 40 is 40 milliliters, and you can see that going down. We want to make sure we're following the numbers that count up so that we know we're counting the milliliters of liquid that are in there. If you started with 50 and you were pouring liquid away, you could use the measurements on the left-hand side to see how much you had poured away. So we're using the measurements on the right-hand side. That's very important. There are 9 small lines between each milliliter line. So each small line is 0.1 times the large line. Remember, the large lines were in groups of 10 milliliters, right? 40, 30, 50. So the small lines will be 0.01 times 10. That means they're each 1 milliliter. So 41, 42, 43 would be those small lines. Next, we find the large line that is closest to our meniscus, in this case, closest to what we're measuring, but smaller. So the one that's closest but smaller is 40. So we start off with 40 milliliters. Now we use the small lines, and we see that the bottom of the meniscus is closest to the 2 milliliter line. So 40 milliliters plus 2 milliliters gives us 42 milliliters. So you can see, even though this was volume and the other was length, reading the lines is a very similar process, just with the volumes. Make sure you're measuring from the bottom of the meniscus, because if you looked at the top on the sides, the meniscus, the top is a little bit higher, and you might have said 43 milliliters, whereas 42 is correct. Now, once we know how to get that data, we need to talk a little bit about organizing and using data. Practice in making and reading charts, tables, and lists of data will help you record your measurements accurately. This is something you've probably done before. We just want to run through the basics to get you out of summer and back into school mode and really ready for what's coming. So, a few tips for making a useful data table. Always use a title or heading to explain your data table. Here we have height and mass of unknown items. Label the rows and columns clearly. Rows go across to the side, columns go up and down. So the rows are labeled item 1 and item 2, and the columns are labeled item, height, and mass. Finally, make sure to list the units of your measurements. So we see the heights here are in centimeters, and the masses are in grams. When you're reading a table that someone else has made, you're going to look for the same information. So first, read the title or heading to find out what the table contains. This one is about drops of water balanced on a penny. If you've ever done that lab, it's really cool. Don't be surprised if you see it coming later. But this is just a sample of data from a lab that students have done. And it's the drops of water they were able to balance on a penny. Check the row and column labels for information. We see that the heads or tails facing up is what we're told about in the first column. Number of drops of water balanced on the penny is what we see in the second column. Check the units of measurement carefully. If you just run right to this chart, let's say you had someone ask you, how many milliliters of water fit on the head of a penny? If you just read the number 13, you might say 13 milliliters. But we need to check the units carefully, and we see in the column header it says number of drops. So it's 13 drops that were balanced on the head of the penny in this particular experiment. Now, we would need a little more information to know if each of those drops is 1 milliliter or smaller or larger than that. So that's where the units become really important. All right, that's everything for today. Just to summarize, selecting the correct instrument and reading it carefully are important skills for accurate measurement. And you want to use titles, headings, and units to make and read data tables. If you're looking for another way to study this information, use the PowerPoint file or the Making Measurements file in the Resources section of the class page. To go over this PowerPoint in more detail, you can click through it step by step to see those measuring processes if you need to see them again a little bit slower. And the Making Measurements file is more like a textbook style and contains some of those tips about measurement as well. Alright, if you're done with this, you're all ready to move on to the assignment. And if there's anything you need any help with at any time, make sure that you call, email, BBIM, or look for me in the Cyber Cafe because I am here to help. Take care, everyone.